Hello and welcome. We're going to be going over a problem today. So the problem is right here. It says that find the last non-zero digit of the factorial of a given non-negative number n. We're going to proceed with the UMPIRE process to figure this out. So the first step is the understand step. So what do we want to understand? We want to understand the inputs. So the input is a non-negative number n. Non-negative number n. And then what's the output? The output is the last non-zero digit of the factorial. Last non-zero digits of factorial n. And so we have a few example problems here. So we can just look at these examples. If the input is n is 4, then the output is 4 because n factorial of 4 is 24, so the last digit is 4 without any trailing zeros. And so if we have an example where we do have trailing zeros, we have an input where, for example, n equals 5, and the n factorial of 5 is 120. And so since there's a 0 here and we skip that last digit and go to the last digit, the last non-zero digit, which is 2. So we have an output of 2. So now that we have a couple examples under our belt and understand the problem better, we can match this. So our match is with the problem with finding the first digit of factorial and also some problems with numbering patterns. So those are possible matches, and then we have to, in this case, do we have a loop that we have to go over? Yeah, we have to go over a loop, and then we have selection statements, and we have some of that. You have for exceptions, cases, yes, and so we have a basic understanding of the match of this problem. Now we can move on to the plan. So the plan is we're going to first enter the inputs, enter inputs, and then we are going to select statements, or we're going to write a function with inputs and select for exceptional cases 0 and 1. So we write out what we're going to return there. And then we write a for loop initializing with initializer fact to iterate over factor product of i's from 2 to n plus 1. And then we write a while loop to check for divisibility by 10, and we subtract the 10 factors. The factors of 10 of the factorial. And so that way we have a smaller number that we can save. So stores x times y instead of x times y times 10 to the n. And the other thing is that we can easily get the last value or the last digit of x times y this way. And then we select, then we print, or maybe I should say return last digit of x times y. And then we print statements. Okay, so now that we have a plan, we can go ahead and implement this plan. Okay, so first we have the inputs, and then we have the function definition, last digits, not 0, and so we have first if n equals 0, then we have return 1, if n equals 1, then we return 1, and then we initialize factorial. So for I in range from 2 to n plus 1, we have update the factorial. So we want to multiply by I. And then we can write a while loop, while fact mod 10 equals 0. Then fact equals fact mod, or subtract off the 10. So we divide by 10, and then we exit, and then we return, exit the for loop, and then return fact mod 10. So that's going to be our function, and then we can print last digit not 0 and put in. We pass all the tests. So there we have it. Now we can review our function. So we can step through this Python tutor code right here. And so what we see is that we just go through, we print the function. So we go into the function and we check to see if the number is 0 or 1. If it's not, then we initialize factorial. And then we go into the for loop and multiply by starting I equals 2. And then we check the while loop and see that there's not a factor of 10. In fact, so it goes back to the for loop, and I equals 3, and then it keeps on going until we see a factor of 10. So we see a factor of 10, then it goes into the while loop, and it subtracts off that factor of 10, and we keep on going to iterate over the i's, and while subtracting off 10 along the way. And then in the last part of our function, we just return fact mod 10, which is going to be, if we go to the previous one, we see that we're just going to, this is the previous one, we're just going to subtract off the or take the last integer value from factorial, which is 8. So we're done. And that's a review of our steps. So now we can go back and we can ask the question, what's the evaluation of our function? So since we have this for loop, the for loop has time complexity um, or of order n, and the while loop has time complexity log O log of n. So subtracting off the zeros gives you a time complexity of log of n, and together we have a time complexity of n log n. And the space complexity here is, we didn't store anything, so it's just O1. So now that we've seen the solution, we can ask if we can find a better solution, a solution with time complexity that's less than n log n. And so there is, so we can check over here on geeksforgeeks.org. So there's a better solution. The solution is this formula right here, where we write a function that checks if the tens digit of factorial is odd or even, and then it gives this recursive solution. And so if we look at the implementation here, we save the first 10 digits, the last non-zero digit of the numbers from 0 to n, we save that first, and then we have this application of this formula. We check whether the tens digit is odd or even, and we have this in integer in 10 mod 10, which extracts the tens digits, and then mod 2, so checks if the tens digit is even odd, and then returns this recursive formula if in case the tens digit is even, and this recursive formula for the case where it's odd. And this shows that we can show that this function is of time complexity O log n and space complexity O log n. So that's a wrap up. So thanks for watching.